Naming the simple binary ionic compounds was straightforward enough. Now we need to level up. We need to figure out how to name ionic compounds that contain transition metals. As mentioned in the past, transition metals can transition their charge, and that is what makes it a little bit more challenging. And that is what we're going to learn in this lesson today. By the end of this video, you should be able to employ the original concepts for naming ionic compounds in addition to having transition metals in the compound. So what is it about these transition metals that makes it so much more challenging? Well, they have to get special treatment. Since they can transition their charge, they're not always going to become +1, they're not always going to become +2, or they're not always going to be -1 like say chlorine or fluorine. They have the ability to decide they want to be +1 one day or +2 the next. Just like you or I can change our clothes on a day-to-day basis, these transition metals can transition the charge that they're wearing depending on the situation they're in. So before we can name them, of course, we have to figure out what charge these transition metals possess in any given situation first. And we will always show this charge when we're naming these compounds in the format of Roman numerals. So Roman numerals, like in the image over there, you've got the 1, the 2, the 3, you've got the I and the V. That's not intravenous, that is actually number 4 in Roman numerals. We're using that kind of numerology to indicate the charge within a name if it happens to have transition metals present. So for example, if we're looking at chromium 3 chloride, which is that purple stuff right there, you can see that the charge of the transition metal chromium is shown in the name as a Roman numeral 3. So in this case, we would know that this transition metal is wearing a +3 charge out to the picnic brunch today. Maybe tomorrow, when it's paired with a different atom, it wants to wear a +4 charge instead. It can transition the charge that it wants to wear depending on where it's going, depending on who it's hooked up with. And the way that we would pronounce this chemical is chromium 3 chloride. So you will physically say the charge, the Roman numeral, that's in parentheses after the transition metal. So now if you were given a name like chromium 3 chloride from before, what would that look like as the formula if we tried to make the molecular formula for it? Here are the steps in order to do so. The first step is to write the cation atomic symbol. So the transition metal, you want to write the atomic symbol. So for chromium, you would write Cr with its charge as a superscript. So you're just going to take the Roman numeral, whatever the Roman numeral happens to be, and put it as a plus whatever that number is. So in the example I've given here, the IV is 4 for a Roman numeral. So that would literally be +4. And I just wrote chromium, Cr, with the +4 as a superscript to indicate the charge. Step 2 is to look at the anion and write the atomic symbol for whatever the anion happens to be, and also put its charge as a superscript. Typically, the anion is the one that will have the charge that's always the same. So like your chlorine with -1, in this case I used the example of fluoride, fluorine, -1. So you would write its atomic symbol of F with its charge that'll become in the upper right-hand corner superscript. And the last step, step 3, is then to balance the charges overall between these two atoms, just as we always have in the past. So drop and swap, or if you want to do the more complicated multiply method, that's up to you. I personally always choose drop and swap because that's easiest. So I just put the 4 down here, the 1 down here. I don't have to show the 1 because it's implied that it's there, and we end up with CrF4. That's how we get from the written name to the molecular formula if an ionic bond happens to include a transition metal. All right, you think you got it? Go ahead and pause the video here and see if you can answer the molecular formula for the following ionic compounds, including transition metals, on your own. And pause now. All right, let's give these a try. Tungsten 6 oxide is our first one. First and foremost, where the heck is tungsten on the periodic table? Well, anytime you see a Roman numeral, you should be looking in the transition metal region, because if you see a Roman numeral, you know it has to be a transition metal. It's wearing a different charge than the other atoms with predictable charge will always wear. Remember, this column has the +1, +2, skip all the transitions, +3, ±4, -3, -2, -1. So the transition metals will always have the Roman numeral. So if you happen to ever see Roman numerals, you can automatically look in the transition metal region to find what you're looking for. Tungsten is represented by W on the periodic table, right there. So we're going to write a W, and the Roman numeral is indicating a charge of 6. So we're going to write +6 in the upper right-hand corner of the W. Oxide is oxygen, so that's O. And oxygen is right here, it forms a -2 charge. We'll put that up in the upper right-hand corner. Then using our scandalous method of drop and swap, we're going to take this number and put it down here, and take this number and put it down there. So what we end up with is W2O6. This can be further reduced down because we have common multipliers between 2 and 6 to W1O3, or again, anytime there's a 1, we just get rid of it. So really, this ionic formula could just be symbolized as WO3. Whoa, 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 that's the answer? Get it? Next is iridium 3 sulfide. Iridium is right here, and sulfur is over here. Iridium with the 3 Roman numeral means a +3 charge on the IR. So we would write IR +3, and sulfide, sulfur, is in the same column as oxygen as before, and all of these form -2. So we'll put a -2 in the upper right-hand corner. Let's do our drop and swap. We'll put the 3 down here and the 2 down here. And that gives us IR2S3. How about tin 5 fluoride? First we have to find tin in our transition metals. And tin is right behind my head, right there. And fluoride is right there for fluorine. So SN is the symbol we need to use for tin, and the Roman numeral present is 5, the V. So we'll put a +5 in the upper right-hand corner, and fluorine is -1. Let's take those superscripts and drop and swap them. We'll take this 5, put it down here, take this 1, and put it down there. So we end up with SN1F5. Anytime we have 1 in the bottom, get rid of it. We don't need to show it. So we now know how to go from the name with the transition metal to the formula, but what if we have the formula and we need to get to the name? We still need to figure out what the charge on the transition metal is before we can do that, because we need to know what to write in the parentheses for Roman numerals. So this is a little bit more challenging because you have to reverse engineer it. You kind of have to think backwards here. But just pretend you're like one of the Hardy Boys, or maybe you're Nancy Drew. That used to be my jam back in the day. You are a sleuth, a super sleuth, and you're just going to figure out this puzzle by working backwards and looking at the anion's charge to determine the transition metal cation's charge. So for example, if we were given PbF2, we need to think about Pb as the mystery that needs to be solved. Pb is our transition metal, and so I put a question mark there. We don't know what Pb is wearing today. Might be wearing a winter coat, might be wearing a tank top. We need to figure out what charge Pb happens to be wearing today, based off of the anion. So our anion is fluorine, F, and we have 2 of those. So that's why I wrote 2 separate F atoms. Each F atom brings a -1 to the table, brings a -1 charge, and I got that from the periodic table. So together, our fluorine atoms equal -2 charge. Because of this, and because we know that the molecule must be overall neutral when together, we know that Pb has to be something -2 that equals 0. So Pb's question mark here is essentially saying what -2 from here will give me 0. Hopefully you recognize that the question mark has to be 2. +2 -2 gives me 0. So in this situation, Pb is wearing a charge of +2. So moving on to step number 2, now that we know the charge of Pb, we need to write it in parentheses after its actual name using Roman numerals. So now instead of PB, I would actually write out the word lead because that's what PB stands for. And I'm putting that +2 charge that we determined from before in parentheses after lead as Roman numerals. So if you don't know all the Roman numerals 1 through 10, I highly recommend you write them down to be able to use them for naming transition metal ionic compounds. And the third step, last but not least, is to take a look back at that anion, make sure that it ends in "ide" as we always have before, and put it after your transition metal with the Roman numeral charge. In this case, we would say not fluorine, but fluoride for our anion. Here's another example for you as a summary for transition metal naming, including Roman numerals up above in case you haven't written them down yet. We're going to name FeCl2. We know that Fe is a transition metal, and it's iron. That's why females are named females, because we're actually iron men. Get it? So first we need to determine the charge that's on iron, our transition metal. So we're gonna write that as Fe what? Cl -1. And now there's 2 of those Cl's for FeCl2. So since chlorine is always a -1 charge, and we know we have 2 chlorine atoms from that base subscript 2, we know that there's an overall -2 charge on the chlorine. So ultimately what we're saying is what -2 gives me 0. So what charge would iron Fe have to be wearing in order to cancel out the -2 and equal 0 overall? Hopefully you saw, just as before, that the only number that will subtract from 2 and equal 0 is +2. So Fe must have a charge of +2 for that to make sense. We would write that then as iron 2 in parentheses, chloride, always ending in the ide. Do you think you can do it? I certainly hope so. Go ahead and pause the video here and give it a try before I give you the answers. V stands for vanadium, so we're going to write vanadium. And we don't know the charge on vanadium. V what? We do know, however, that oxygen has a -2 charge, and there happens to be 2 of those present by this subscript. So overall, we have a -4 charge. So really, what -4 gives me 0? That would happen to be +4. So after vanadium, we need to write the Roman numeral in parentheses for 4. And then we need to write the anion, which is oxygen, except we end it in ide, oxide. How about PbBr2? PB, not peanut butter jelly time, but PB, lead. So we're going to write the word lead for PB. And we don't know the charge that lead has. We need to be a super sleuth and figure that out. We're going to write PB ? And we know that Br from the periodic table forms a -1 charge all the time. That's the charge it likes to wear every day, all day. And there happens to be 2 of those. So there's 2 Br atoms, each bringing to the table a -1 charge. So overall, Br is giving us a -2 charge. So what -2 gives me 0 for PB? Hopefully you see that it's +2 -2 gives me 0. So after the word lead, I need to write 2 in Roman numerals in parentheses, and then finish that up with our bromide, ending in ide. Next up, Ni2S3. Ni stands for nickel. I have good news and bad news. I found a nickel.
The good news is I've named my nickel Philip. What's the bad news? It's a girl nickel.
The bad news? It's a girl nickel. For Ni2S3, nickel and sulfur, we're just gonna do a reverse drop and swap here. We're gonna take the 3 from down below and put it up top, and take the 2 from down below and put it up top on the sulfur. So what we get then is Ni plus 3 sulfur minus 2. Double check this, look at your periodic table, and you'll see that sulfur does in fact form that -2 all the time. So in this case, we have plus 3 as our mystery solved for nickel's charge. We would write this then as nickel, parentheses for the Roman numeral, 3, and then sulfur would end in ide, sulfide. And last, but certainly not least, we have Mn, manganese, and Cl, chlorine. Let's write out manganese. Every time I say manganese, I feel like I should say Gesundheit afterwards. Manganese, Gesundheit. Now we have manganese written for Mn, and we don't know the charge on our transition metal Mn, but we do know that chlorine, Cl, forms a -1 charge. There's only one chlorine atom present, so what -1 gives me 0? +1, of course. So between these two, we know that manganese must have a +1 charge. I'll write that as a Roman numeral 1, and then write chlorine ending in "ide" for chloride. So out of all the transition metals, there always has to be an exception. There always has to be a problem child or two. So in this case, the two problem children happen to be zinc and silver. They are always going to form the same ion, just like the halogens all form -1, just like oxygen always forms -2. Zinc and silver are transition metals that actually don't transition their charge. They just happen to be lumped in the transition metal area, and they keep their same charge. They form the same ion every single time. So for these, you don't need to show the Roman numerals because you're going to treat them just like we treated our fluorine, chlorine, hydrogen, lithium, sodium, all of those guys that form the same charges all the time. So for silver, you should recognize that silver is a +1 charge all the time, every day, all day. And the way you can remember that is silver is your #1 stomach. And for zinc, zinc forms a +2 charge. You can remember that easily because zinc, the Z kind of looks like a 2 anyways. So zinc forms a +2 charge all the time, every day, all day. Of course, there's more than just one exception. There's also the reverse exception here, where there are two metals that are not in the transition metal range on the periodic table, but they do transition their charge. So they act like a transition metal, they're not in the transition metal area on your periodic table, but you do have to show Roman numerals because they do transition their charge. And those two problem children happen to be lead and tin. So lead, Pb, can form +4, +3, +2, +1. It can transition that charge, and tin can do the same. Sn, +4, +3, +2, +1, can transition its charge. So keep in mind that for Pb and Sn, they can transition charge, and you do need to show Roman numerals for those guys too. So in summary, for ionic naming overall, we have our simple binary ionic naming, which we learned in the previous lesson, which is probably the easiest thing: cation plus anion ending in "ide." However, when we include transition metals over there, you need to write the cation symbol first with the charge as "what is it?" and play like you're a super sleuth. You have to figure out what that is based off of the clues that the anion leaves you with. The anion will tell you the charge that the cation must be in order that the entire molecule results in a neutral overall charge. Once we've determined the transition metal's charge based off of the anion's charge, we'll show that charge in parentheses as Roman numerals in the written out name, and as always, end our anion in "ide." Go ahead and make sure you understand this content before you move forwards. Test yourself before you wreck yourself, and try and fill out this table behind me. I have the question of either a molecular formula or a provided name. First, figure out the charge of the metal ion. So again, this would be the transition metal in these cases. And then use that charge, or use the charge of the anion, in the case of where you're given the molecular formula first, to figure out the name and or formula of the compound in the column behind me. I'll do the first one with you, and after that, good luck. If you have questions or would like to know the answers to the rest of these, please mention in the comments below, and I'd be happy to oblige and upload another video with all the answers. This first one, however, is PbO. Pb stands for lead, and O stands for oxygen. The charge of the metal ion in this case, we don't know yet. We need to write Pb ? We do know that O has a charge of -2 all the time from the periodic table. So in this case, what -2 gives me 0? That would have to be 2. So the charge on the metal ion, our Pb, would have to be +2. And then the name or the formula of this compound, we're already given the formula, so we do need to figure out the name here, would be lead. And we know the charge is 2, so the Roman numeral would be 2. And finally, oxygen would go to oxide. I hope that helps you name all those transition metal compounds. Be sure to give me a quacks up and subscribe to the channel for more educational content. See you later.
No ducks, no glory.